Do you struggle with bulging corners or uneven top surface in your 3D prints? If so, you are in the right place. Stick around and let's fix it together. Hi, I am Remy and welcome to my channel. Today, we are diving into the world of 3D printing tuning. We'll explore common issues like bulging corners caused by pressure buildup, uneven surface due to incorrect line width or over extrusion, the benefits of pressure advance to minimize filament oozing, and techniques like ironing for achieving a clean top layer. So let's roll up our sleeves and optimize those prints. Now let's delve into the details of bulging corners and uneven top surface. Bulging corners. What you see highlighted in the circle are called bulging corners. It's a prevalent issue in 3D printing where corners tend to bulge or become uneven due to various factors. One significant cause is the slowing down of the printer near corners, leading to pressure buildup in the nozzle. This pressure isn't adequately compensated by the extruder, causing filament to bunch up and result into bulging corners. Uneven top surface. The area highlighted in blue is uneven top surface. Uneven top surface can occur due to factors such as line width exceeding the nozzle size or over extrusion. This can result in a surface that's not smooth or level. Before we explore the next set of topics, let's take a moment to ensure we are on the same page. We have covered bulging corners and uneven top surface, addressing common issues and potential solutions. Now, let's continue our journey by discussing pressure advance and technique for achieving a clean top surface. Pressure advance. Pressure advance is a valuable technique to minimize filament oozing during non-extrude or travel moves and reduce blobbing during cornering. Its effectiveness depends on the type of extruder, nozzle, and the filament being used. Pressure advance compensates for pressure variation by pushing extra filament during acceleration and retracting it during deceleration. High acceleration combined with excessive pressure advance can lead to extruder skipping if it lacks the torque to push the required filament. In such cases, lowering acceleration may be necessary. Once pressure advance is tuned, consider enabling a small amount of retraction, disabling Z lift on retract, and enable wipe while retracting in the slicer setting. These are the recommendations. However, this adjustment may vary depending on the specific printer configuration. Clean top surface. Achieving a clean top surface is crucial for the overall quality of the print. Several methods can help, and here are some. Top surface pattern. Consider using concentric patterns for the top surface to improve its appearance. If your top surface pattern is monotonic, reducing the top surface line width can help achieve a smoother finish. Ironing. Ironing is another effective technique for achieving a clean top layer. In this process, the printer's nozzle lightly smooths the top layer to remove imperfections. It's important to note that implementing ironing may require an increase in infill percentage to ensure optimal results. Now let's see the actual configuration changes. First, we'll see pressure advance. Once you open OrcaSlicer, under prepare page, click on the calibration button. OrcaSlicer comes with few pressure advance calibration, so click on pressure advance, and here we have two major options: extruder type and method. Extruder type depends on your printer configuration. If you have a direct drive extruder, you need to select this. If you have a Bowden type extruder, you have to select the Bowden. I'm having direct drive, so I'll select this option. Next, we have to look into the method types. We have three method types here: PA tower, PA pattern, and PA line. We'll see PA tower first. So we'll click on this and select OK. And here it loads this tower. We'll slice this. Once you print this, look at the height on these corners, this all corners, here, this corner, this, and this, and measure the distance from here to here. Do not measure this mouse here. You should not consider the measurement over here, but somewhere in the middle, and see at which height you are seeing sharp corners. So if you go higher and higher above, and if you see the corners are not sharp enough, you can stop the print. There is no point in continuing further. Next, we shall see PA pattern. This is another good option, PA pattern, where you need to look at these corners here. So over here, if you look, you will have bulging corners, and over here you need to see for sharp corners. So avoid the lines which are bulging out over here, and the lines where you don't have sharpness. So look over here where you have sharp corners. The last method, which is my favorite method, is PA line. I use this method to do the test. The previous two methods, they are good, but I prefer to use this. The first method, where you have the tower, I feel filament is wasted, because you need to do pressure advance test for each and every brand and the type of filament, like PLA, ABS. You need to do this test. If same type and same brand, you do it only once and it should work. So over here, if you are using the PA test, let's say if you are using the PA pattern and PA line, make sure you have a very good flat bed, because this test highly depend on how flat your bed is. Now let's understand the settings available. These settings, these are the same setting for any of this method you select. I'll be discussing on PA line, so I'll focus on that. Start PA line is the very first line, end PA line is the last line, and the steps is how many lines to be printed from 0 to 0.1. Now let's start a PA calibration test with PA line. PA start will keep as it is, also the end PA 0.1, but we'll change this PA steps to 5, that is 0.005. Click OK, and we'll slice the plate. So this is the very first line. This is start PA and this is end PA, and in between are the steps we have defined, the PA steps. So we are doing incremental steps of 0.005. Before we start to analyze, I would like to highlight one thing which I forgot to mention in the start. Pressure advance feature is specific to printer firmware, the firmware what you are running on the printer. So whether it could be Kilpper, Marlin. I'm using Kilpper, so in Kilpper you need to enable pressure advance in the printer.cfg file. In Marlin you need to compile it while you are compiling the firmware, and it is called linear advance. So now we'll start to analyze. This particular calibration test is at a higher value, that is pressure advance value is done at an increment of 0.005. So we have this line which are printed with a gap of 0.005. So right from PA start, that is 0, till PA end, that is 0.1. We need to look for lines which are somewhat consistent, because with this calibration, which is the very first calibration, since we have a higher value, we won't find a line which is consistent from start till end. So we need to look for lines which are almost close to consistent. So if we look into here, so let me zoom in here. Over here you can see the width start, and over here it is consistent, but over here it's not. It is very thin over here, then extrudes more. So this particular part is not consistent. If you go up here, over here, yes, it looks consistent. So over here if you look, a higher value we have which looks consistent over here. Now we need to analyze both the side, this and this side. So we'll look at this side. Over here we don't see that consistency like what we see this particular area. So over here the consistency is not there. So now this particular line will look over here at this. These lines will analyze. Over here you can see it is extruding. These are blobs over here, not good. So somewhere in the middle we have some consistency, which is also not correct. So we need to do second calibration test, considering lines from over here, since this line somewhat look consistent also over here. So the next print or the next calibration what we will do is considering the start at 0.06 and ending at 0.075, this line. So from this line which is 0.06 till this line which is 0.075. So this line. Now let's do the second test. Prepare, calibrate, pressure advance. Over here, now we need to select the start of the line which is close to the acceptable range. Start PA, we'll set this to 0.06 and end will be 0.075. So we'll start with 0.06 and end with 0.075, and steps increment will be 1, that is 0.001. Click OK and slice plate. Now we have fewer lines to analyze, so the start and the end and the PA steps. Let's analyze this and see which lines come to the nearest acceptable extrusion width, which is same from start to end. Now let's analyze our pressure advance calibration setting 2. This is the second set of calibration that we'll analyze now. Again, we have to look for this area over here and this particular area. So if you see over here, this area, it all looks okay. Over here, this is not okay over here. And this over here looks okay. Now for this particular area, if you start from top, over here this doesn't look okay. Over here also not okay. Down this area is not okay. This somewhat looks okay. So we'll do another test with another granularity and start at this line 0.064 and we'll end at this line 0.66. So we'll zoom in and see over here. So these lines will reprint, redo the test within this area or within this lines. Now we'll do our third calibration test. So our start will be 0.064, end will be 0.066, PA steps will be 0.0001. So we have 3 zeros and 1. Click OK and slice. Now we have more lines to analyze since we are at more granular level. So let's analyze these lines and see. Now let's analyze our calibration test result, the third one. In this, if you see at this area, we have almost everything looks okay. This area also, it's very difficult to judge, but all the line seems okay over here. But we'll just zoom in and see if we can find a sweet spot. So we'll zoom in this particular section and see. So we'll start from top. Over here you can see it's a little bit, the width is less compared to this and this. As we move down, we'll try and find out the best sweet spot. Again, this is a personal preference. Your preference may vary. If you all see more than one line, or let's say 2 or 3 lines matching to the same width, so this, let's say this line and this line looks all same, then it is recommended to select a higher value. So in this case, let's say if these 3 lines are same, then the recommended value will be 0.0656. So this one. So over here, so all looks okay. Very difficult to judge. So we'll come from bottom and see if anything. This is okay. No, this is little thicker over here. This also not okay. Not okay, not okay, not okay. So this line not okay, not okay, not okay, not okay. No, no. Somewhat looks okay here. This also looks okay. Okay. So what, for me, what I see, this lines looks okay for me. So I will select this over here. It's still little bit wider over here. Here also this looks to me a sweet spot, which is 0.0651. So this line will be 0.0651. So we'll set this value and check our further test prints. Before we proceed further, let's see how we can set pressure advance in OrcaSlicer. So we have to edit the filament profile, which is this one over here. Click this edit preset button. Under filament, you need to enable pressure advance over here and set the value, the desired value what you want to set. You have to set it over here. Second place to set is under advance. You can set that over here like this. So set underscore pressure underscore advance equals 0.0651. If you set over here, then make sure to disable this, otherwise this will override whatever you set under advance. Here the advantage of setting over here is you can set it based on some condition. You can put some if conditions and set it, like for example, if you have a different nozzle size for the same filament, if you are printing with a higher nozzle like 0.6, 0.8, 1 mm, then you can set it over here as a if condition. If you have, in my case I'm using just one nozzle, 0.04, then I don't need to set over here. I will just enable over here and this will take care of that. What it actually does is in the G code, it will actually set like this. If you analyze the G code, this will be there in the G code. Even if you enable this value, this option over here and set this in G code, you will get exactly like this. In this test print, pressure advance is disabled both in OrcaSlicer as well as in printer and Kilpper printer.cfg. It is disabled. As you can see here, the red circles is where bulging of the corners is there in all four corners, and at the borders is where the surface is uneven. We have over extrusion over here. Too much of filament is being laid out over here. That's because of the pressure built into the nozzle. It's not able to cope up with the speed, and when it comes over here it has to slow down. So we'll see a further test print by enabling pressure advance. Now let's see this test print where pressure advance is enabled and value set is 0.0651. You can see we have a clear improvement over here. This print looks very good, but if you touch over here, like in this corners over here and over here, you will feel little bit of roughness. So we'll see how we can avoid this in future test print, which I will show later. And also if you see these lines are not joined over here properly, not touching to each other, that's because the shape of the nozzle and the size of the nozzle also depends. Bigger the nozzle size, you will have this kind of gaps, and smaller the nozzle size, you will have more lines touching to each other. We'll see how to improve this top layer. Once pressure advance is enabled, in this test print you can see these gaps, or the lines are not joining to each other at this particular wall. That's because after enabling pressure advance, we have less amount of filament being pushed as it reaches to the end of over here to the wall. It reduces the pressure as it slows down. The nozzle slows down, and then the pressure is also reduced, so less filament is pushed out. When the nozzle comes over here like this, it will do a turn and come back over here. So here it goes over here, then slightly moves this side and will come here like this. When the next one goes over here, it goes further on, and that is where this gaps comes in. Higher the nozzle diameter, wider the gap it will be. To compensate for that, we have to reduce the number of lines or the width of the top layer. We need to reduce that, and that will compensate for it. So you will have more number of lines touching to each other. That should be done only for the top layer. Another option to avoid these gaps is to change the top surface pattern. So this is monotonic. We need to change to concentric. So that will be going into square like this. The nozzle will go from like this, like this, like this, like this, all over into square, and finally it will complete somewhere over here. So that way it will be you'll not see these gaps, but all the lines will be touching. We shall see in the further test print. Now we'll do a test print by changing the top surface line width. So over here this is set to 0.3. So we'll see how it looks on the top surface. Now we'll see this test print where we have improved in the line joining. Over here we have less gaps. There is slight, which is not noticeable, but if you zoom in you can see over here. So with this, the change over here is the line width for the top layer is reduced. It is set to 0.3, the width of this line. So if you see these lines over here, diagonal lines, this width is set to 0.3 only for the top layer. So if you compare with the previous print, we have this gaps over here where this line is 0.4. The width of the line is same as the nozzle. I'm using a 0.4 nozzle, so the line width is also 0.4. So for this print I have reduced the line width to 0.3. Here is another test print. In this, the line width is same as the previous one. The change over here is this is a new parameter with OrcaSlicer 2.0.0, where you can enable small area flow compensation. It is still in beta, but it works fine. If you enable this option, this is the area where you will see improvement, where it goes into this area is very short to print from here to here. This way, when the area to print for the nozzle to travel from this point to this point, it's a relatively small distance. For this kind of small distance, if you enable small area flow compensation, then you have slightly improved top layer quality. We'll compare that with the previous print, which is here. Let's zoom in over here. See this part, it's less messy compared to this layer. I mean, it's not fully perfect, but much better compared to this area. We'll see the bottom side as well. So this area also we will see over here. If you can see this particular area, it's much improved over here. This particular area, just ignore it. This is the nozzle where it is ended. This is the end of the nozzle printing, where it stops, and then it will retract and finish the print. So ignore this area. So this area you have to look, this area and this area. You can see that there is clear improvement over here. Though it is in beta mode, it does a very good job. Now let's see how to enable small area flow compensation. You can find it under your profile, under this profile. Then under quality, you need to scroll down. It will be over here, small area flow compensation. As you can see, it is in beta. You need to enable this, and then flow compensation model will pop up. This is the default value. It says the format of this particular parameter is extrusion length and flow correction factor, comma separated. So the first one will be the extrusion length, and the second one will be flow correction factor. This is another test print. In this test print, the top surface pattern is set to concentric, and the top surface line width is set to 0.4 mm. As you can see in the where the walls are, top surface and the walls, the joining part, there is no gap, but here a few gap. I don't think this is due to any change in the pressure advance or the pattern. When I did the second test print, it was okay, but I was not able to capture the photo of the second print. Now let's see how to change the top surface pattern. Once you open OrcaSlicer, go to your filament profile, which is this one, and under strength, you will find it over here, top bottom shell. So top surface pattern, it is set to monotonic. If you slice this, you will see these are diagonal lines, and to change it to concentric, you have to click here and change it to concentric now, and then slice the model. So this is how it will be printed. Now let's analyze another test print. The difference here is ironing is enabled. So for ironing, it is selected only for the topmost layer. Line spacing is 0.1 mm, the speed is 15 mm, and flow rate is 15%. So the ironing flow rate, the amount of filament it needs to extrude is 15%. If you see here, this particular area, it looks very shabby. That's because based on the setting that you have for ironing, you will have this kind of output. For ironing, my recommendation is to have a higher speed and lower flow rate, but that again depends on the test, depends on your printer and the filament also. So if you go slower and you have higher flow rate, then the filament will be extruded over here itself, because it has very less line spacing. So the lines over here are too many at a 0.1 mm distance, so it goes back and forth at the same location for a long time, and that is why you have over extrusion over here. But once it picks up on speed and has a larger distance, it looks quite good. One thing to note, if you have enable ironing, you have to make sure that you have enough infill. Otherwise, if your infill density is less, you will have this kind of output. So you need to have quite high infill density. For this, the infill density I normally set for all of my prints is 15%. For this print, the infill density is 35%. Ironing was first introduced in Cura. I don't remember the exact version. I would not recommend for ironing, because it depends on what your configuration is for ironing. If the filament, the melted filament remains in the nozzle for a very long time, because the flow rate must be very less, and the amount of filament, the melted filament remains in the nozzle, will be there for a longer period. That is, the same amount of filament will be heated over and over again. Due to that, there might be discoloration due to overheating of the filament. So I would not recommend. I personally don't use ironing. It's up to you guys to decide whether you all need or you all don't need. Now let's see where we can find ironing in OrcaSlicer. So in your profile over here under quality, and if you scroll down, you can find over here ironing type. So let's enable this. So make sure it is enabled. For you select this option, topmost surface only, and if you slice, these lines are very fine now, and we have lots of lines. That is to achieve the smoothing. It will do like this. So other option that we have is pattern. We have rectilinear and concentric. Ironing speed, I would recommend this should be fast enough. Flow rate, this should be as less as possible, and the ironing spacing, the spacing between these lines. So the next line will be placed at a distance of 0.1 mm. Again, I would like to highlight, this is your personal preference whether to use it or not. My recommendation is not to use due to the reason which I said before. Thank you guys for watching this video. Do let me know in the comments how do you find these videos. If you like, don't like, also do mention in the comment, because that motivates me to make such kind of videos. God bless. Stay safe.